Hello, algebra students. We're at the independent practice now. Now, when I was looking at this question for the independent practice, my first thought was it made me think about the summertime and when I go to baseball games. My favorite team is the New York Mets, and the Mets have a mascot, which is a guy who dresses up in a silly costume and goes around. His name is Mr. Met, and he's a giant baseball for a head. So if you're not a fan of the Mets, you might not know who he is. But this is Mr. Met. Okay? He runs around the stadium. At some point, in the middle of the game, Mr. Met has this thing. See this thing he's holding here? This is a t-shirt cannon. Now what they do is him and a couple of other people, he has like a couple of assistants, and they run around and they load this t-shirt cannon with a wrapped up t-shirt. So it's a t-shirt wrapped into like a cylinder, like a can, that shape. And they stuff it in that thing. It's an air rifle. You see the air tank over here by his elbow. Right there. See that? So that's the air tank. And he fires that thing. And it goes up, he shoots it into the crowd, and you get a free t-shirt if you catch it. Now the only problem I have with Mr. Met is that whenever he does this, I am a teacher, so I am not in the expensive seats. So I'm kind of sitting up high. So this is what it looks like to me. I'm up here. And what happens is, Mr. Met is all the way down here on field level. Let's see, I'll draw him with a giant head and a little body. Just like he looks like in real life. Now he's got his t-shirt cannon. And what he does is he fires the t-shirt up into the air. Now what happens is because I'm so far up, it never makes it to me. It comes down and it lands somewhere here, and some rich guy over here in that section gets the t-shirt. And it always misses me, never reaches me. So of course I have a smile, I'm sad. I'm not very happy about that. So Mr. Met here, his baseball hat on, fires that thing, and it never reaches to me. But what I thought about was look at the shape that the t-shirt travels. T-shirt travels in a parabola. So that means it has certain aspects of it. In physics, we learn about how stuff travels like this. Okay, we call this two-dimensional motion because we're only concerned about up and down, left and right, like our graphs. So two-dimensional motion looks like that. Kind of like Mr. Met fired a t-shirt. There he is. Keep Mr. Met in mind. Now, let's go to our problem. It says during halftime of this game, they use a sling, they launch a t-shirt with initial upward velocity, 64 feet a second. The t-shirt is caught 35 feet above the court. How long did it take the t-shirt to reach its maximum height? How far above the court level will it be? What is the range of the function that models the height of this t-shirt over time? That's a lot of stuff to get into one problem. But we do know one thing. We know what it looks like. It's going to look like this. But actually, it's kind of going to be reversed. Because I'm going to say that Mr. Met is over here. And the guy catching the t-shirt is over here. So we're going to imagine ours travels like that. So I know somewhere, well, on this graph, on the bottom here, we can figure this out. Just get a sketch of it. So I'm going to say this is about 5 feet in the air. Now why I'm saying 5 is because right here, it's showing that it's launched from 5 feet. So it's not launched at 0. It's not launched from the ground. Just like Mr. Met has the cannon in his arm, he's not laying on the ground shooting it to me. He's shooting it from 5 feet in the air. So this is what it's going to look like. Now, the question is, what time is it at its highest point? Now they gave us a function here. I'm not going to have us worry about the function. We're going to look at it this way. Plus v t plus 5. This plus 5 represents this right here. Okay, so now, next question. How do we solve this problem? Well, I don't want to find this. I don't want to find this. We've got to find other things here. So let's look at first how high it is. Well, it gets to its highest point when it reaches the axis of symmetry, which, good thing for us, we did earlier. We know it's x equals negative b over 2a. Now, that will tell us, since this is t, and this is h, height, how long will it take the t-shirt to reach its maximum height? So this is going to be how long? Okay, so that's pretty good. We got this. This is easy. So how long? Negative b, well, here's my b, here's my c, and here's my a. Negative b, negative 72, over 2 times negative 16, negative a. Plug in these numbers. 2 times negative 16 is negative 32 over negative 72. And so I put these numbers in, and I get in from my calculator, clear, negative 72 divided by negative 32. And the number I get is 2.25. So, at 2.25 seconds, 0.25 seconds, it will reach its maximum height. Now, what is that maximum height? Well, I have to plug all these numbers in. Okay, so I'm really going to do one equation here. Negative 16, 2.25 squared, plus 72 times 2.25 plus 5. Wow, looks like a lot of numbers. Okay, let's see what the maximum height this t-shirt will reach. So I'm going to put this in here. I'm going to say, well, second, I can't make this any dimmer. I'm sorry, people. I'm going to put on the light. That will help. Okay. So, plugging these numbers into my calculator. Negative 16. Very clear. Negative 16 times 2.25 squared, close parentheses, plus 72 times 2.25 plus 5. Now, this is not that hard to put in. We're just plugging in numbers. I'm going to hit enter. And that's how high the height, this number here, I'll write it in another color, green, the maximum height this t-shirt reaches is 86 feet. Well, that's pretty cool, 86 feet. Now the next part is, how long is this thing in the air for? I'm just going to do an estimation here. I'm going to say y equals, I'm going to put in our numbers again, negative 16x squared plus 72x plus 5. I'm going to graph. So it said it starts at about 5, comes down, and that is t right here is where it lands. Okay, so I could look at this. I could say second trace. I'm going to look look for one of the zeros. Now I'm going to say, they say this is the left side. Yeah, I'll make this the left side. Then the right side, I got to come all the way around. I want to be on the right side. Oh, there it is. I'm on the right side over here. So there's a left side and the right side. I'm going to hit guess. And there we go. Now, the total time it is in the air is 4.56 seconds. Now, 4.56 seconds is pretty interesting because it's almost twice what the time going up to its highest point is. And in physics, you're going to see this always happens. The maximum time in the air is double the time it takes to get to that height. So you spend half your time going up, you spend half your time going down. This is a hard question, but it's interesting to look at. I like it from a physics standpoint, and it shows you how using our information we can predict a lot of things. We know how long it takes to get to the maximum height. We know how long how high it's going to get to. We know exactly how long it's going to be in the air. Now, if I want to see how far it travels, I would do this same problem again, this red one here, but instead of 2.25, I would put in another number. So the range of the function, how long does it go, would give us this answer. So, very interesting. All right, I'll talk to you guys later.